One of the things I find most interesting about being an addiction researcher is that every time I give a talk, like this, someone usually comes up to me afterwards and says that their mother, brother, uncle has suffered from addiction. Now, while I admit at first this was a bit jarring, it always serves to remind me that the work we do in our lab isn't just about rats giving themselves cocaine. It's about uncovering what brain regions make it nearly impossible for an addict to avoid taking a drug. To do this, I use a rodent model of addiction, where rats are placed into a chamber like this and allowed to press a lever for cocaine. Along with each cocaine infusion, they are also presented with a short light and tone cue. As you can imagine, over time, rats begin to associate this light and tone cue with the drug, much in the same way that an addict may associate drug paraphernalia with their drug of choice. Now, once rats are stably responding and reliably receiving cocaine infusions, they are moved on to the next stage. At this point, cocaine is withheld from the animal, similar to when cocaine is withheld from an addict when they enter a treatment facility. Now, at this point, when rats are placed into the chamber, pressing the previously cocaine-paired lever will have no consequence. No light and tone, no cocaine, it's a complete dud. So, over the course of a few days, rats learn this change and press the lever at much lower rates. And it is at this point that we can then study relapse. Many addicts report that when they return home from treatment, simply seeing the cues they once associated with their drug of choice makes it nearly impossible to avoid taking the drug. To mimic this situation, following treatment, our rats are once again presented with the previously cocaine-paired light and tone cue. And even though they are not receiving cocaine, just seeing these cues is enough to increase their lever pressing or cause relapse. So, I decided to investigate a region known as the insular cortex, which has previously been shown to be involved in nicotine addiction, as well as a variety of drug-associated cues, to determine if this region is involved in cued relapse. To do this, I inactivated the structure by injecting a pharmacological agent into the structure immediately prior to one of these cued sessions. And what I found is that inactivating the insular cortex led to a decrease in lever pressing during one of these cued sessions. In other words, rats without a functioning insular cortex were completely able to avoid relapsing. In contrast, inactivating the insular cortex did not affect other types of relapse, such as cocaine prime. This information is extremely valuable, as it is the first to demonstrate that the insular cortex may be one of those regions that makes it nearly impossible to avoid taking a drug. And we hope that this information will lead to treatments that are more specific and more successful.